वेलकम टू फिजिक्स मेड इजी चैनल। आज का जो हमारा मेन टॉपिक है वो यंग्स डबल स्लिट एक्सपेरिमेंट है और इसके ऊपर हमने आज जो बेसिक इंपॉर्टेंट कॉन्सेप्ट्स हैं नीट जेई मेन और जेई एडवांस के लिए ये स्टडी करने हैं। एंड वी आर स्टार्टिंग फ्रॉम द वेरी बेसिक्स फॉर दीज थ्री कम्पिटिटिव एग्जामिनेशन नीट जेई मेन एंड जेई एडवांस्ड. And starting from the basis, we will reach to the toppest level, which will be relevant only for JEE Advanced. So first of all, I will remind you a few of the formulas. For example, position of bright fringe, x is equal to n small lambda capital D by small d. And n is equal to 1, 2, 3, 4, first, second, third, and so on bright fringes. Position for dark fringes is given by x is equal to 2n minus 1 into lambda by 2 into capital D by small d. Capital D is the distance of screen and small d is the for n is equal to 1, 2, 3 for the first and second and third darkness fringes. Small d is the distance between the sources. Now the width of each bright and dark fringe, beta is equal to lambda into capital D, distance of screen, and small d is the distance between the sources. When the entire apparatus is immersed in transparent medium of refractive index mu, when the entire apparatus is immersed in a transparent medium of refractive index mu, for example this case, then the fringe width beta dash is equal to lambda dash d by small d, and this is lambda capital D divided by mu into small d, and this is beta by mu. Angular width theta is equal to small beta by capital D and small lambda by small d. And let me remind you from the diagram about these parameters. Now let us have look from the diagram. In this diagram, this is D. Small d is the distance between the two sources, and x is the distance, is the position of bright fringe or dark fringe, and capital D is the distance between the source and the screen. So this is about all the parameters. And now the very first concept is quite clear. Very simple kind of MCQ can be asked like this: beta is equal to small lambda into capital D. This is the distance of screen. For making your learning curve easy, I shall be repeating some of the things time and again. So in this case, this D is the distance from screen. This is the distance from screen. Between source and screen, capital D, its value is large. Always remember, even if you have to take an answer, then D is in meter and this small d is in mm. If you have to take the answer numerically, always remember there's a small d is in mm and capital D, distance of screen, this is in meters, 1 meter or 100 centimeter, 90 centimeter, 120 centimeter, like this. The first numerical is this problem is quite easy. Now all other things are same. So we are given fringe width for one wavelength is this, and the fringe width for the second wavelength is given, and that is to be calculated. So very simple way, this is the wavelength. For this wavelength, for example, this is lambda 1, for this the fringe width is this, and for second wavelength lambda 2 fringe width is given, and we have to find out the wavelength. We just know that beta is directly proportional to lambda. Simply it means beta 1 is directly proportional to lambda 1 and beta 2 is directly proportional to lambda 2. Divide these two, we will get the answer. Very easy concept. And the second is this. So these are just warm-up concepts. Young's double slit experiment, frequency of the light is given, distance between the center of the adjacent fringes is given. This is the distance between the centers of adjacent fringes. This is in mm's and it's noted 0.75 mm. So this is beta. Screen, as I have already told you, is in meters. This is capital D. This is given. What is the distance between them? Wavelength is frequency is given. You can calculate wavelength from here. Calculate wavelength, and I think apply simple formula. Nothing to be explained. Just warm up. In Young's double slit experiment, two slits are NA apart. This is small d. This is small d. The interference fringes for wavelength lambda. This is lambda is given. Now this lambda is given. Formed at a distance of 80 centimeter away. So capital D is given. How far is the second bright fringe from the central fringe? Put n is equal to 2. And make use of the formula x is equal to n lambda capital D by small d. All the parameters are given, just put n is equal to 2. And second is how far is the second dark fringe from the central. This is again a very easy problem. So here we shall be using this 2n minus 1 into capital D by small d into lambda. Now put n is equal to 2. So this will be just equal to the fringe width, lambda d, no, 3 by 2. So you will make use of this formula. Here there will be a factor of 2 in the denominator. To put n is equal to 2, you will get the answer. Nothing typical, very easy. So till now I think you are well warmed up. Two slits are made 1 mm apart. 1 mm apart, distance between the two slits small d is given. Apart from the screen 1 meter away. It means this is capital D is given. What is the fringe separation when blue green light of wavelength? This is used. Now this is wavelength is given. I don't think so. So beta is to be calculated. Everything is given. Lambda is given. Capital D and small d is given. So just nothing to worry about this thing. In Young's double slit experiment, two slits are separated by this distance Na apart, means small d is given. This is small d is given. Are illuminated by wavelength lambda. So this is lambda is given. The screen is Na meter away. This is capital D. From the slit, find the distance of the second bright fringe and second dark fringe from central maxima. For bright fringe, I shall be using this formula n lambda capital D by D. Secondly, put n is equal to 2. And for dark fringes, use this. I will use dash here. This is 2n minus 1. Into capital lambda d by small d. Use this. So you will make use of this second bright fringe. And I think you just put n is equal to 2. Nothing new. Very easy. So I think till now you will be fully warmed up. And here is the first relevant problem. Now, beam of light, two wavelengths are given in this. One wavelength is lambda, other wavelength is also given, is used to obtain interference pattern. Distance of screen is given, so this is capital D. Capital D is given. If the two slits were separated by 0.28 mm, so this small d is given. Calculate the least distance from the central maxima where the bright fringes of the two wavelengths coincide. Now we know that the position of bright fringe xn is equal to n lambda capital D by small d. The position of bright fringe is directly proportional to lambda. Now what is important is for larger wavelength, for them to coincide, n will be larger for smaller wavelength. So now if I assume for red 800 nm is larger, it means for that I shall be using small n. This is for red. So this is for red. I shall be using this symbol for this. And now second is for yellow. Let it be n plus 1. So this n lambda 2 capital D by 2, and here I will be writing plus 1. So this is n plus 1. Now both of them are to be equal. This and this, they are to be equal. It means n lambda 1 for simple language, n plus 1 lambda 2, they are equal. Now from here lambda 1 is known, lambda 2 is known. We just need to calculate the value of n. So for the sake of simplicity, if I fill this is here, it will be 800 and here it will be 600. You don't need to worry about the units. This is 4 by 3. 4 by 3 n is equal to n plus 1. From here I can make the calculations and find the answer. So this problem has exactly of this nature. They have appeared in your MCQs. Now the next, this is the problem in YDSE. So if the screen is moved towards the source, it means D is decreasing. The change in the fringe width is given this much. This change is given. And if the distance between the slits is given, now what is there? Actually what is happening, I will show you here. So this was the distance D. Now this distance has been decreased. Note it down. So it has been moved towards the source. So we have given, for example, I know in the first case, I will have to move down. Kindly bear, so because I have lost track of the page. So if we will do in front of the diagram, that will make you understand in a better manner. So this is the case. Yes. So now first case is beta is given lambda capital D by small d. Now we are moving this screen towards the source. We are moving this screen in this direction. We are moving this screen in this direction. And the new distance comes up to be D dash. Now this is equation number 2. Obviously if D decreases, B dash will also decrease. So if I perform this operation, beta minus beta dash is lambda by capital D, D minus D dash. Now if this is given to us, and so what is given? Now let us see the problem. In this problem, he says that the change in fringe width is this, delta beta is given. So in this case, delta beta is given. So this is delta beta. Delta beta is equal to beta minus beta dash, and this is lambda by D into this. I can also write it as delta D. So now this delta D, where delta D is D minus D dash. Now from here, this is given. We can calculate any other remaining factor. Now let us see what he has asked. Calculate the wavelength of light. We have just to calculate the wavelength. If the distance between the slits small d is given, now the screen is moved, delta d is given and delta b is given, both are given, and this small d is given. So everything is given, we have just to calculate the lambda. We have just to calculate the lambda. So now in this concept, so very easy, even if you are a bit familiar with differentials, you can very easily understand. Now in this particular problem that we were tackling, in this particular problem, so what was there? This factor was given, I meant to say this whole factor was given, this was given, and this was given. And if you know all these factors, you can calculate lambda. Even you don't need to do the mathematics that I have done. If you are a bit familiar with differentials, so we can just write delta beta here. If lambda and d are constant, then delta beta here simply. Simple. Even you don't need to do the mathematics that I have shown you this. If you are familiar with the differentials, this clue is important for JEE main students, so they should know this fact. Even we do this in the chapter of errors in +1. So now let me go through the next concept. To find the ratio of intensity at the center of bright fringes to the intensity at the point 1/4 of the distance between the two fringes. Distance between the two fringes, 1/4 means 1/4. 1/4 means 1/4. So first of all, find the ratio of intensity at the center, means phi is equal to 0. For phi is equal to 0, this is the formula. We are well familiar with the formula. This is the basic formula for intensity. I will be putting phi is equal to 0. And as the sources are coherent sources, for sustained interference, B should be equal to A. And this becomes the formula. Phi will be 0 and I will take it as I1 will come out to be 4Ka square. I think cos 0 is 1. Everyone knows that cos 0 is 1. So we will get this result. I think there up to this point there should be no doubt. For the newcomers or the dummies, I will mention put B is equal to A here, A square plus 2A square. This will be 2A square. This will also 2A square will come out. So 2Ka square 1 plus cos phi, cos phi, we will put phi equal to 0, cos 0 is 1. So in this way, so this will be the brightness at the central level. Now what finally he is saying? He says, to the intensity at a point 1/4 of the distance between the two fringes from the center. Distance between the two fringes from the center is fringe width, beta. So this is 1/4 of beta. Now in this case, nothing is changing. Capital D will remain the same. Actually, for solving intensity, I need phase difference. Phi. Now, if I fill this value, I will get 1/4 of lambda d by small d. Now this is constant, this is constant. This just tells that lambda changes to path difference lambda by 4. Lambda by 4. Now I want phase difference. Whenever for path difference you have to calculate phase difference, just replace lambda by 2 pi. And I'll replace it now. And it will come out to be pi by 2. So this is phi. Pi by 2 is phi. So I will put phi is equal to pi by 2. If I put phi is equal to pi by 2, now we are quite familiar with this formula. I is equal to 2ka square 1 plus cos phi. Now here I put phi is equal to pi by 2. Cos pi by 2 is 0. It means I2 is 2ka square into 1 plus 0 is equal to 2ka square. So we know that I1 is 2ka square, I2 is 4ka square, and if I take the ratio of the two, it will come out to be 2. Now the most important factor to remember in this case is this is the bottom line of this numerical or of this concept. So what is he says that it is 1/4 of the, I will read the line exactly, the intensity at the point 1/4 of the distance between the two fringes. Distance between the two fringes is fringe width. And now if fringe width is reduced by 1/4, capital D distance from the screen, distance between the slit small d, both are same. It means lambda has been changed to lambda by 4. So the path difference, so this is the path difference. So I want phase difference corresponding to path difference lambda by 4. And now for that I will replace lambda by 2 pi, it will come out to be pi by 2. And for calculating intensity, I need phase difference. For phase difference, I need path difference. So it's an important problem, important concept. Next is find the maximum intensity in case of n identical. Now here I have, note this line, small n identical waves, each of intensity I naught if the interference is coherent and incoherent. In case of incoherent, there is just simple algebraic addition of frequencies, intensities. Now I have got n identical waves. N identical waves means, for example, intensity of one wave is I naught. I have got up to n such waves. N such waves. Now I will take the resultant of the first two. Resultant of the first two means this is the mathematical expression as I1 is equal to I2. This is I naught. I will fill these values. And also maximum intensity, he is talking of, note this line, maximum intensity, because the intensity is maximum. Maximum intensity can be at phi is equal to 0, and for maximum intensity we know that R square is A plus B square. This is resultant, and for intensity I will write this as under root of I naught, because amplitude is equal to under root of intensities and intensities are equal, square of this. So in this case for 2 I can write, here I will write I2. I2 indicates for 2 waves. This is 2 into I naught. By mathematical induction, I can say for 3, it is I3, 3 into I naught square. Remember that intensity of all the waves, they are equal. For n, logically for n, I can write this thing. For n, I max will be this n times. So if I now write in my handwriting, this is I max. So all these are, I will just skip this step into I naught, and this is square. This will be n square I. Now if this is the case of coherent sources, remember this is the case of coherent sources. Now incoherent sources, just simple addition, and you know it is the maximum intensity. It means I shall be simply adding, and the average, note that average of cos phi is 0 here, so we shall be just simply adding them. Simple addition means I max in case of non-coherent sources will be n I naught. In case of coherent, this is the expression that I am writing. This is for coherent. This is n square I naught. So in coherence, intensity is more than in case of incoherent sources. This is the case of incoherent sources with double tick. This is a case of coherent sources with one tick. Coherent sources and incoherent sources. Just you can remember it. It may be useful directly. You can remember this as a shortcut as well, that I max is equal to n I naught in case of incoherent sources, and I max is n square I naught in case of coherent sources. Now the next case. So this is in Young's double slit experiment. Lambda is given, D is given, capital D is given, minimum distance from the central maxima, for which intensity is 1/2 of the maximum intensity. Now, the formula for intensity is written here. For maximum intensity, put phi is equal to 0. And cos 0 is 1. It means IR in this case, find the minimum distance from the central point for which the intensity is 1/2 of the maximum intensity. I will have to reform it. I naught is the maximum intensity. And first I will calculate maximum, not like this. So this is I maximum will be equal to, now this is 1. So this whole factor will be 1 because cos 0 is 1. So this will just come out to be this. This is I max. Now what he is saying, minimum distance 1/2 of maximum intensity. So this is 1/2. Now IR is 1/2 of I max. I max is 4 I naught. It means just 2 I naught. Now I shall be again making use of this formula. Again making use of this formula. So what this formula is, IR is 4 I naught cos square phi by 2. Now this is 2 I naught. I will put here 2 I naught is equal to 4 I naught cos square phi by 2. And this will give me, there is a bit of lack of space, so I'm making space available, and I have enlarged the image so as to make the space available. So from here, the whole of this will cancel. So here I was having 2 I naught. So it means cos square phi by 2 is just 1 by 2. Now this implies pi by 2 is pi by 45. This is pi by you can say 4. Pi by 4. This is just pi by 4 means 45, and phi equal to pi by 2. Now from here onwards, this is phase difference. Now what he has asked, maximum distance. Now I have to find out distance corresponding to phi by 2. Always remember, when you have to find out distance or path corresponding to phase, replace pi by lambda divided by 2. So it means x here will be equal to half of pi, and here half of lambda divided by 2, and this is lambda by 4. Lambda by 4. What is the value of lambda here? Lambda is 500. Divide it by 4. It will be 125. 125 nm. So in this whole problem, the basic fact is you have to find out distance corresponding to the phase phi. Distance, all other things we are well familiar with it. What was important, I have just to find distance corresponding to this phase. So I have told you a shortcut, just replace lambda by pi by lambda by 2. Again I will remind you this fact. If you need phase difference, change lambda from path difference, change lambda to 2 pi. So if you need path difference, then change pi to lambda by 2. So this is from, I will like to say, x to phi. X means path difference, phi means phase difference. This is from phi means phase difference to path difference. So these are the two ways, and with these words I finish this lecture. So I have introduce you in an appropriate way to the basic concepts, and again in the end of the lecture I will request all of you to kindly view these videos. If there is any problem, then inform me, and if you like it, then kindly share with others. So thank you very much. With these words I finish this lecture.